students, welcome to physics class. Okay, in this class I want to discuss about the motion in a central force field and nanophysics. This is unit 2. Okay, let us discuss some basic things. Okay, what do you mean by the central force and classification of the central force? First, a force is said to be central force if it is always directed towards a fixed point. The forces exerted by two bodies, one each from the action and reaction pair, and are equal and opposite according to Newton's third law of motion. This is called the central force. Okay, the force is always directed towards the fixed point. There are two types of the central force. One is bounded motion and another one is unbounded motion. So what do you mean by the bounded motion? In this type of motion, the distance between the two bodies never exceeds a finite limit. Okay. The bounded motions are the motion in which the distance between the two bodies are never exceeds a finite limit. For example is the motion of a planets around the sun. This is example for bounded motion. Second one is unbounded motion. So what do you mean by unbounded motion? In this type of motion, the distance between the two bodies is infinite initially and finally. Okay, this is known as unbounded motion. So example for unbounded motion is scattering of alpha particle. Okay, so next, reduction of two body problem to equivalent one body problem. Okay, this may be asked for 12 marks. This is important. Okay, see the diagram. This is the center. These are the 2 points m1 and m2 of mass m1 and m2. r1 is a distance from 0 to mass m1, 0 to particle of mass m1. r2 is a distance of particle 2, that is mass m2. Okay, next, consider the motion of two particles. The motion of the two particles of mass m1 and m2 of mass m1 and m2 separated by distance r. Okay, separated by distance r. Let F external be the total external force acting on the system. Similarly, let F internal be the total internal force due to interaction between the two particles. See, consider the motion of two particles of mass m1 and m2 separated by distance r. Let F external be the total external force acting on the system. Similarly, let F internal be the total internal force due to interaction between the two particles. That is, F external equals to external force. It is equal to F1 external plus F2 external, because there are two particles of mass m1 and m2 with distance r1 and r2. So the force of those particles is F1 external and F2 external. Okay, consider this as a expression number 1. Okay, where F external is total external force. F external is the total external force. F1 external and F2 external are the forces acting separately on the two particles. According to Newton's third law, According to Newton's third law of motion, see, F12 internal, it is internal force, that is equals to minus F21 internal. Okay, consider this as a expression number 2. F12 internal equal to minus F21 internal. Okay, these forces being the action and the reaction, the equations of motion of the two particles, motion of two particles individually and as a system of two particles can be written as system of two particles can be written as M1 R1 double dot equals to F1 external plus F12 internal. Okay, consider this as expression 3. See here, M1 R1 double dot means what? See here, force F equals to MA. Okay, M is as it is, acceleration is A equals to R double dot. So this is first particle, means M1 R1 double dot equals to F1 external plus F12 internal. Similarly for second particle, M2 R2 double dot equals to F2 external plus F21 internal. This is expression number 4. Okay, next MR double dot equals to F external. This is expression number 5. Here F1 external is the force exerted by particle of mass M2. Here F12 is the force exerted by particle of mass M2 on the particle of mass M1, on the particle of mass M1 and vice versa. That is capital M equals to M1 plus M2. Okay, this is expression number 6, where capital M is the center of mass and the position vector of the center of mass, and the position vector of the center of mass of the system. Okay, see what we did here. Consider the motion of two particles of mass M1 and M2 separated by a distance r. Let F external be the total external force acting on the system. Similarly, let F internal be the total internal force due to interaction between the two particles. Okay, that is F external, that is equals to F1 external plus F2 external, because there are two particles of mass M1 and M2. So the force of those particles are F1 external plus F2 external, where F external is total external force, F external, F2 external forces acting separately, F1 and F2 external forces acting separately on the two particles according to Newton's third law. Newton's third law means what? If every action there is a equal and opposite reaction, means negative term. F12 internal equals to minus F21 internal. these forces being the action and the reaction. The equations of motion of two particles individually and as system of two particles can be written as m1 r1 double dot equals to f1 external plus f12 internal. See here, m1 r1 double dot means what? F equals to ma. M is at as it is. A means acceleration. That is a equals to r double dot. Okay. So m1 r1 double dot. This is first particle. Similarly for second particles. Okay. Next, f equal to mr double dot equals to capital M R double dot equals to F external. Here F112 is the force exerted by particle of mass M2 on the particle of mass M1 and vice versa. Capital M is M1 plus M2, where M is the center of mass and the position vector of the center of mass of the system. Okay. Next, where capital R equals to m1 r1 plus m2 r2 divided by m1 plus m2. Consider this as expression 7. Okay. Position vector of particle 1 is relative to particle 2. What? The position vector of particle 1 is relative to particle 2 is given by small r equals to r1 minus r2. Okay, this is expression 8. Now multiply by m2 to equation 8 adding with equation 7. What? Multiply by m2 to equation 8 and add equation 7. See here, multiply by m2. First write this term is 7th equation, means 7th equation is what? m1 r1 plus m2 r2. Next here, r m1 plus m2 is there, means r m1 plus r m2. Okay, that is m1 plus m2, that is r. Okay, this is equation 7. Next, multiply equation 8 by m2. Equation 8 by m2 means this is m2 r1 minus m2 r2. Next, m2 r. Okay, then see here, m2 r2 get cancelled. Next, m1 plus m2, take r1 as a common, equals to r m1 plus m2 plus m2r. Okay, this means capital R1 is r m1 plus m2 divide, okay, r plus m2 divide by m1 plus m2 small r. Okay, this is r. Consider this as expression number 9. Okay, next, similarly multiply by m1 to equation 8 and subtract it from 7 from equation 7. See here, equation 8 is r equals to r1 minus r2. So multiply it by m1 and subtract it to 7. 7 is m1 r1 plus m2 r2 equals to capital R m1 plus m2. This is equation 7. Next, multiply 8 by m1. m1 r2 minus m1 r2 equals to m1 r. Next, subtract. Minus plus minus. Okay, m1 r1 get cancelled. Next, r2 m1 plus m2 equals to capital R m1 plus m2, subtraction means minus m1r. Okay, this means, so small r2 equals to r minus m1 m2 get cancelled, minus m1 divided by m1 plus m2 divided by r. Consider this as expression 10. See here. Okay, capital R equal to m1 r1 plus m2 r2 divided by m1 plus m2. Okay, r small r equals to r1 minus r2. Just see the multiplication. Multiply by m2 to equation 8 and add equation 7. Okay, then we will get r1. Next, similarly multiply by m1 to equation 8 and subtract it from 7. Then we will get r2, r1 and r2. Multiply equation 3. Multiply equation 3 by m2. Multiply equation 3 by m2 and equation 4 by m1 and equation 4 by m1 and subtract. Just mathematical steps are there. That means m1 m2 r1 double dot minus r2 double dot equals to m2 f1 external minus m1 f2 external plus m2 f12 internal minus m1 f21 internal. Okay, next step, m1 m2 r double dot equals to m1 m2 f1 external divided by m1 minus f2 external divided by m2 plus m1 plus m2 f12 internal. Consider this as expression number 11, where f12 internal is minus f21 internal. See here, multiply equation 3 by m2. What is the equation 3? m1 r1 double dot equal to f1 external plus f12 internal. Is there? No. So multiply that equation by m2. Then it will give m1 m2 r1 double dot minus r2 double dot equals to m2 f1 external minus m1 f2 external plus m2 f12 internal minus m1 f2 internal. Next, see here, r1 double dot minus r2 double dot. In equation number 8, r equals to r1 minus r2. So here r1 double dot minus r2 double dot means that is equals to r double dot. So m1 m2 r double dot equals to, take m1 and m2 as a common. Next, f1 external, m2 is here, no, then divide by m1, same, divide by m2 plus m1 plus m2 f12 internal. See here minus m1 f21 internal is there, but already using the Newton's third law, f12 internal equals to minus f21 internal. Okay, next, dividing equation 11, dividing equation 11 throughout by m1 plus m2, throughout by m1 plus m2. This is equation 11, means m1 m2 divided by m1 plus m2 r double dot, that is equals to m1 m2 divided by m1 plus m2, remaining term as it is, f1 external divided by m1 minus f2 external divided by m2 plus m1 m2 divided by m1 m2 f12 internal. Okay, next, see here, mu r double dot, it is equals to mu f1 external divided by m1 minus f2 external divided by m2 plus m1 m2 get cancelled. Next, f12 internal. This is expression 12. See, where mu equals to what? M1 M2 divided by M1 plus M2, called reduced mass. M1 M2 divided by M1 plus M2. Mu is called the reduced mass. It's called the reduced mass. Or this expression can be rewritten as 1 by mu equals to 1 by M1 plus 1 by M2. Okay, consider this as expression number 13. Next, if no external force is acting, this is all for external forces acting. If there is no external force, if no external force is acting, external force is acting, then F1 external plus F2 external equals to 0. This is expression number 14. Okay. If external force F1 external and F2 external are proportional to the masses of the particle, if external forces F1 external and F2 external proportional to the masses of the particles on which they act, produce equal acceleration in the two particles. Equal accelerations in the two particles. If F1 external divided by M1 equals to F2 external divided by M2, then equation 12 reduced to what is the equation 12? Mu r double dot equals to mu F1 external divided by M1 minus F2 external divided by M2 plus F12 internal, that is equation 12. So that reduced to mu r double dot equals to F12 internal. This is expression 15 and this is 16. This is the equation of motion of a particle. This is the equation of motion of a particle having mass equal to reduced mass. Reduced mass is what? Mu. And moving under the action of force F12 internal. The reduction is equivalent to replacing the system by a mass and considering the acceleration produced in it due to the interaction of force if the mass of one of the particle is extremely large as compared to that of the other, that is m1 is greater than m2, then the reduced mass is if m1 is greater than m2, mu equals to m1 m2, reduced mass is m1 m2 divided by m1 plus m2. Okay, m2, take m1 common, 1 plus m2 by m1, as m2 by m1 tends to 0. Mu equals to m2, motion in a central force field. Mu equal to m2, this is the motion in a central force. Okay, mu equal to m2, this is motion in a central force. Here it is the end of reduction of a two body problem equivalent to one body problem. Okay, thank you.